weekend, 5th graders. Hi guys! I hope you're enjoying this cozy rainy Sunday morning or afternoon. We're going to get into lesson 27, hopefully, before the children attack. We are going to be doing division, and this division is going to involve decimals, and you guys did a terrific job with this on Friday, so we're really just going to, do you like Georgie's jammies? We're just going to continue the practice, and I just need you guys to be very thoughtful through every single step. Document your work on the right side of your page. Separate that with a line of learning. And really what we're doing, you guys, now is synthesizing all of the amazing learning that we've done so far in Module 2. And we are just kind of applying it to more complex problems. I want you guys to remember that we do have our celebration of learning coming up. So our focus, yay, Mr. Calmer, so excited about a celebration of learning. Our focus, sorry, this is insane. Our focus is going to be really leaning in to some word problems, because we'll have some really good word problems on our next celebration of learning. And you guys, oh, Cal, do you want to say goodbye? Say goodbye, 5th graders. Have a great week.
Bye-bye.
You say bye-bye?
Bye.
Bye, 5th graders. Say go Bears.
Go Bears.
Go Bears.
Have a great math week.
Bye.
Bye. Okay, guys, let's look at some problems here. Hey, kiddos, so we are in lesson 27. As you can see, we're dividing. I thought this was a really, really interesting problem, because I think a lot of us would see 24 and 48 and think, oh, 48 divided by 24, 2. Wrong. This problem is so helpful because this really requires us to be very thoughtful when we're setting up these division problems. As this expression reads, we're dividing 24 by 48. 24 ones, and we're dividing them into 48 equal groups. So here's another level of interest. 24 ones divided equally into 48 groups. Well, I actually can't do that because I don't have enough, so I only have 24 ones. I don't have enough ones to divide evenly across 48 equal groups. So this is how we handle that. I'm going to go ahead and insert our decimal point, and I'm going to go ahead and label the fact that we have 0/10. And now we're going to think about this number as 240 tenths. Well, if I have 240 tenths, which we do right here, we can absolutely divide 240 tenths evenly across 48 groups. See what I did there? Okay, so whenever we are including our decimal point, please make sure that we bring that straight up. Now we need to think, how many 48s can I fit into 240 tenths, of course? Really what we're thinking about now is imagine those 240 tenths, and we're dropping them into equal groups of 48. Let's think about this. 48 is pretty close to 50. Let's just do some skip counting by 50 because it's just so darn fun. We're trying to get, oops, I pressed that darn button on my pen. We're trying to get close to 240. And I'm feeling like we're pretty close. So 48, we've rounded that to 50 because they're pretty close. So I'm thinking 1, 2, 3, 4. I think 48 is going to fit into 240 approximately 4 times. So let's go ahead and divide this side of our page with a line of learning, and let's work through 48 times 4, which 4 times 8 is 32. And then we have 4 times 4 is 16, plus 3 is 19. So I feel like that's going to work for us. So let's go ahead and look at this 4. We're going to put the 4 right above the 0 because this is communicating that we can squeeze when we're looking to drop 48 into 240 or 240 divided into 48 equal groups. We're looking at about 4 groups with some left over. So let's look at 4 times 48. I love that I already have that on standby. I do not love that I keep on pressing that darn button on my pen. So now we have 240 minus 192. And let's see what we come up with. 10 minus 2 is 8. Oops, I forgot to follow through here. So what we're looking at now is a 13 minus 9 is 4. And then we have 1 minus 1. Oh dear, I'm doing my check. And this number is not smaller than that number. They are the same number. If my remainder is 48, that's telling me that I can actually squeeze one more 48 into this quotient. So do not fear, we can handle that. That's actually very important information. I'm going to go ahead and just erase. Ooh. Yeah, this might be, I'm going to keep that borrowing work up there. So let's go ahead, oops, we need to get rid of our difference. So this is actually going to be really nice. I think a few of you are thinking ahead about a remainder. So we actually found out that I should have gone a little bit further. 8 times 5 is 40. 5 times 4 is 20 plus 4 is 24. So that's looking really nice. This is the magic quotient. That 5 should go over the 0. 5 times 48, as you have seen, my friends, is 240. The difference between 240 and 240 is nothing. So what we have found that 24 divided into 48 equal groups is 0.5 or 5/10. Think about if that makes sense. We're going to think about if that makes sense by checking ourselves with some multiplication. So 24 divided evenly across 48 equal groups, 5/10 is our quotient. 5/10, keep in mind, you guys, 5/10 is, we can write it in fraction form. 5/10 is also equal to 1/2. So that actually, that's really logical. I like how this is actually coming together here. Let's multiply 48 by 5/10, and we're hoping that we end up with 24, our original dividend. Let's just temporarily pretend like that decimal point is not there. We'll look at that here in a moment. 5 times 8 is 40. And if I'm sounding really whispery, you guys, it's because I'm hiding from my children in Mr. Calaveras' office. And if I raise my voice too loud, they'll sniff me out and then the gig will be up. We'll have 2 toddlers interrupting our math work here. Okay, anyway, so 5 times 4 is 20 plus 4 is 24. We need a decimal point here. 48 times 5 I'm sorry, 5/10. 48 times 5/10. Would our decimal point be here? Absolutely not. Would it be here? Yes, because 48 times 5, we can, I don't know, 5/10. We can temporarily round that to 1. I know that that's essentially doubling the number, but I'm just doing that temporarily so we can think about where our decimal point should be. So 48, our highest place value is tens. By inserting our decimal here, our highest place value here is tens. And indeed, 24 matches with our original dividend. Pretty cool problem. Let's take a look at another one, guys. Okay, buds, I chose this problem because I really want you guys to be very mindful when we're setting up the problems. I'm just going to change the color here. Do not allow your brain or that little math troll that sometimes whispers in your ear, do not allow a math troll to whisper 28 divided by 7. This is not 28 divided by 7, my friends, just like the previous problem was not 24 divided by 12. I think sometimes that math troll says, hey, just flip it around, it'll be easier. No, we don't care for easier. We are completely confident in our ability to assess this problem. This is 7 divided into 28 equal groups, my math troll. Just watch, math troll. We can handle this. So I'm going to be very confident in the fact that I'm setting this problem up correctly. It is 7 divided by 28. And immediately, I think you guys are probably thinking, well, 7 ones actually cannot be, in this form, cannot be divided into 28 equal groups. There's simply not enough 7 to go around. So, in your guys' infinite math wisdom, I hope that you're thinking about this next piece here. We'll go ahead and document our decimal place. We know that the decimal is here in the problem. It just does not show up in the problem because if there aren't any place values to the right of the decimal, it's not necessary to even put a decimal point there. But now we're going to have to actually be strategic and think about how are we going to go about dividing 7 into 28 equal groups. And here's how. So we inserted our decimal. Let's go ahead and bring that decimal straight up so that we don't forget the decimal in our final quotient. If your final quotient does not have a decimal, then it's not going to be the correct answer. So we have our decimal, and now I'm going to document the fact that there are 0/10ths in 7. And now we're going to rethink this number. Now we're going to rethink 7 as 70/10ths. And now with this reframing of the number, now we can absolutely take 70/10ths and divide them equally among 28 groups. I love how this works. It's just magnificent. Let's think about where we shall start. 28 is pretty close to 30, so I'm just going to do some casual skip counting over here by 30 because I love to show off how my hand can skip count, my mouth can talk. It's just really remarkable. I mean, I never cease to amaze myself. I never cease not to amaze myself. So what we're trying to do is we're trying to squeeze as many 28s into 70 as possible. And I'm thinking that 1, 2 is going to be a good place to start. So we have our line of learning. Let's look at 28 times 2. And 28 times 2, 8 times 2 is 16, 2 times 2 is 4, plus 1 is 5. I'm hoping that will work. I'm going to be more thorough because the last problem I was not very thorough and we had to rewind, which is totally okay because rewinding in math is completely possible with the power of erasers. Let's look at 28 times 3 just to be completely confident. 3 times 8 is 24, indeed. And then 3 times 2 is 6, plus 2 is 84. Okay, great. So we know that this is the number. The number is the quotient. This 2 is going to go above the 0 because we want to communicate that 2 28s fit inside 70 with some left over. Now let's go ahead and do our multiplication. So 2 times 28, love the fact that we have that answer standing by there, is 56. Now we're looking at the difference between 70 and 56. I cannot take 6 from nothing, so I'm going to have to go, this 0 is going to have to go next door and say, hey 7, can you help me out? And 7's going to say, sure thing, pal. I'll unbundle. I'll give you one of my 10s. And then this 0 is going to say, oh great, thanks man. Now I'm 10. And we have this guy, 6 saying, hey 10, I need some help. And 10's going to be like, sure thing, brother, now I can give you 6 because 10 from 6, no problem, 4. These are the dramatic stories that go on in my head. We have, right next door, we have 6, we have 5 asking 6 for 5, and 6 says, oh yeah, no problem. Got you, brother. Okay, so now we have a difference of 14. We're going to go up here and think, is 14 less than 28? Thank goodness, yes. We are in the fun part of the module where we don't rewrite remainders as remainders. We clear the space. I'm just erasing that tenths so that we can continue our roof here. And I need to keep on chugging down the division line until we don't have a remainder. So the way that we're going to handle that is that I just documented the fact that we have 0 hundredths here. 0 is a very helpful number when it comes to extinguishing our remainders, which is what we're trying to do here. Now we're going to think about how many 28s fit in 140. Remember we rounded 28 to 30, and so we're looking at 1, 2, 3, 4, approximately 4 28s that are going to fit into 140 without going over. So let's go over here in our workspace. I'm actually happy that I went the extra mile and did that 3. No, I'm not going to do it again. It's very helpful information, Miss C, but you don't have to do it twice. What we're looking for right now is 28 times 4. I'm trying to get pretty as close as we can to 140 without going over. 8 times 4 is 32, and then we have 4 times 2 is 8, plus 3 is 11. That's pretty close, but I just want to be super sure that that is the number that we need. Let's look at, so we have 2, 3, 4, let's look at 28 times 5. 5 times 8 is 40, and then we have 5 times 2 is 10, plus 4 is 14. Hot dog! I'm so happy that I went a little extra there because I think a lot of you are saying 28 times 5 is 140. So when we bring that down, we won't have a difference. So we're almost to the end. Woohoo! So this 5 is going to go above the 0 in the hundredths place value. The 5 is in the hundredths place value itself. And please make sure that things are lined up properly, because as these problems grow larger and larger, if you don't have your place values lined up properly, it's going to be very difficult to make sure your final quotient has the proper place value. Okay, so I have a 0, 0, 5 all stacked neatly on top of one another. 8 times 28 is 140. And as it turns out, when we take 140 from 140, we have nothing left. So our answer here is 25 hundredths. We're going to go ahead and check this using multiplication because we are thorough mathematicians and we love just this boost of confidence that we receive when we use multiplication to check our division. So we're multiplying 28 by 25 hundredths in hopes that we will arrive at 7 ones as our final answer. So temporarily, we'll pretend that this decimal point isn't here. It's kind of difficult because it's giant, but we're just going to blink our left eye and try to ignore it for a moment. 5 times 8 is 40, so we have some double digit by double digit multiplication here, which you guys are so terrific at. 5 times 2 is 10, plus 4 is 14. We're going down to the second level. This 2 is actually, it's not a 20, it's actually in the 20, it's in the tenths place value, but we are thinking of it as 20 tenths. So we're going to need a 0 here for sure. And now we can think about 2 times 8 is 16. Bring our 1 up. I already used you 4, so I'll just casually cross you out. 2 times 2 is 4, plus 1 more is 5. And I have 2 partial products. We'll add them together to find our final product. I'm really good at adding zeros together. 4 plus 6 is 10. And then we have 1 plus 1 plus 5, 7. Well, now we have to think about our decimal place. 28 times 25 hundredths. This is a really tiny number. Where 28 is, we're making 25, well, let's think about it this way. We're making 28 copies of 25 hundredths, a pretty small number. So would the resulting decimal be here? Would the product be 700? Don't think so. Would the product be 70? I'm not quite sure. Let's do some rounding here. Let's think about 28 times, we're going to round this to 1, and see what we get. 28. So the largest place value here is in the tens. Let's use some logic. 70? Could 28 copies of 25 hundredths be 70? I don't feel really comfortable with that. What I do feel really comfortable with is putting my decimal point here, because I can see that I have 1, 2 decimal places documented in 25 hundredths. Same here. And also, remember what we're looking for is to have a match with our original dividend, which we do because we are stars. And we're going to look at one more word problem. Oh no, someone's crying. I hope it's not one of you. I think it's George. Okay, let's take a look at one more problem here, guys. I just could not resist a science word problem. Let's take a look at this one. We have, in a science class, students water a plant with the same amount of water each day for 28 consecutive days. I'm wondering, did they have to come in on Saturdays and Sundays? Those are some dedicated students. If the students use, maybe they're at boarding school, so they live there. If the students use a total of 23.8 liters of water over the 28 days, how many liters of water did they use each day? And then going deeper with how many milliliters did they use each day? Loving all of this. I feel like I need to be writing in green since we're talking about a plant. Okay, so let's make sense of this problem. So there's a very dedicated group of science students. So dedicated, in fact, that they are coming to school on the weekends to water this amazing, magical plant. And this plant gets 23.8 liters of water across, I'm just going to draw a quick calendar, across this calendar, 28 days. Okay, so we have a plant, it's getting a lot of water, it's being watered across 28 days. So we want to figure out how many liters of water did they use each day. So in this, I'm going to attempt to draw water. Oh, it's pretty good. Oh yeah, I feel real good about this. And this watering can, yes, we're just gonna pretend like that's, yeah, this is the watering can. We want to know what are they giving this plant every day, including when they come in on the weekends. Okay, so it looks like we have 23.8 liters spread evenly. Whenever we see same amount or spread evenly, division should immediately pop in your head. 23.8 liters spread evenly across 28 days. So here's our expression, and we are so excited to just jump in. I'm going to switch to blue since we're watering. I'm just going to jump in and go ahead and get to it. So we're looking at 23.8 divided by 28. So 23.8 is snug inside the house of division. We have 28 days outside. So we are looking at, I love this decimal point. I'm just going to go ahead and bring it up so I don't forget about it. So we're looking at 28 going into 23.8. If we look at the first two numbers, 28 into 23, that's not going to work. So I'm going to go ahead and just put a 0. But if we look at this, 238, and of course this would be 238 tenths, we can absolutely now spread 238 tenths evenly across 28 groups. And now I'm going to think about the fact that 28 is pretty close to 30, and then I'm going to do some more of that super impressive skip counting, skipping, da 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 da. So we're looking to squeeze, we'll say 30 into 238 tenths. How many 30s can we get into 238 tenths without going over those digits, 238? 1, 2, 3, 4, 5, 6, 7, 8. Let's look at 28. Don't forget our line of learning. Let's look at 28 times 8. And that will give us some valuable information. 8 times 8 is 64. And then we have 8 times 2 is 16 plus 6 is, did I do that right? Yeah. 8 times 2 is 16 plus 6 is 22. Okay, that actually, I feel like that's going to work for us. So 8 is our quotient. I'll write to now, well, at least the first digit of the quotient. So we're going to go ahead and communicate this properly, because what we're communicating here is that there are 28s that fit into 238 tenths, or 238 tenths when divided evenly across 28 groups. So far we'll have 8 tenths in each group. So far, we'll see what happens. 8 times 28, we have that work over here. It's 224. Magnificent. Let's look at our differences, I suppose, when we're looking at columns. 8 minus 4 is 4. 3 minus 2 is 1. 2 minus 2 is nothing. 14 less than 28. Check. Okay, now I'm going to go ahead and just erase that tenths because we have a remainder and the game continues. We're going to have to put a little addition on the roof. We're going to document the fact that there are 0 hundredths in 23.8, and then we're going to bring our 0 down. Now we're looking at 140 spread evenly into groups of 28. Keep in mind, friends, this is not 140 ones. What we're looking at now is actually 140 hundredths, because we just documented that there's 0 hundredths. Drop that down. So now what we're really thinking about is 140 hundredths spread evenly across 28 groups. What are we looking at? Well, oh, George is laughing now. 28 got rounded to 30. We're trying to get pretty close to these digits, 140. So I'm looking at 1, 2, 3, 4. Let's look at 28 times 4 and see where that gets us. 28 times 4. 4 times 8 is 32. And then 4 times 2 is 8 plus 3 is 11. I feel like we can get closer. Let's try 28 times 5. Notice I'm not erasing that because I actually might need it. 5 times 8 is 40. And then we have 5 times 2 is 10 plus 4. Oh, I love when this happens. 140. Da, 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 da. Why am I so excited about the fact that 28 times 5 is 140? Because what we're working with is 140. Yes. Okay, so 5, you're coming with me. We're going to go zip right above that 0 that we dropped down in our hundredths place value. I feel like I can write that a little bit neater, Mrs. C. So 5 is in our hundredths. Now I'm so excited to look at 5 times 28 over here. And then that is 140. And then that is so exciting because 140 minus 140 is nothing. 23.8 liters spread evenly across 28 days. Well, those hardworking kids gave this plant, no longer a question mark, gave this plant almost a full liter, 8.5 liters each day. One more layer here, you guys. How many milliliters did they use each day? Well, here's the funny thing. Well, it's not funny. I don't know. Is it funny? Probably not. Here's the interesting part. We know that tiny. We know that 1,000 milliliters live inside 1 liter. So what we're looking for is how many milliliters live inside 0.85 liters. So remember this. Converting, we are going to have to say hello to our dear old friend conversions because we have a conversion problem coming up in our next assessment, and it's just really important to know how to do this well. So I'm going to, you guys, unpack, convert, solve, UCS. Oh, I love it. Okay, so we have 0.85 liters is equal to, we're just unpacking. Don't overthink this. Just unpacking what 0.85 liters looks like. Well, 0.85 liters is equal to 0.85, remember this, you guys, times 1 liter. Sorry, skip counting. Kind of invading your space. Okay, so I've unpacked. Great. Now we're going to convert. This 0.85 just comes on down. Come on down, bud. Now we're going to write our expression. This 1 liter is equal to how many milliliters? When we turn our head sideways, remember this liter has to be equal to the milliliters. The reason why we're starting with liters and we're going to milliliters is because we're trying to figure out how many milliliters live inside a liter. So how many milliliters live inside 1 liter? 1,000. Sorry if this is hard to see over the skip counting. Okay, so we've unpacked, we've converted, now we need to solve. 0.85 times 1,000. Hot dog, I love doing problems like that. You know what I really love to use when I'm looking at multiplying something or dividing something by a power of 10? It's like this amazing grid system. It's called a place value chart. Let me tell you all about it. It can support such amazing work. For instance, I'm teasing you guys know this so well. I know that a lot of you have these hanging in your probably above your fireplace, maybe in your bedroom. They're just the most helpful tools. 0.85, we're multiplying 0.85, multiplying 0.85 by 1,000. When we multiply, we go that away because the number will be growing larger. And it's going to go that away 1, 2, 3 spaces because there's 3 zeros and 1,000s. 1,000, we're multiplying 0.85 times 1,000. So let's jump. 1, 2, 3, and drop 8. And then 5, you're coming with me. 1, 2, 3 place values to the left because we're multiplying by 1,000. So I have a blank space here. I know that a blank space can be filled with a 0. So as it turns out, 0.85 liters, you guys, is equal to 850 milliliters. Oh, magnificent. Enjoy your day, you guys. I cannot wait to see you tomorrow. Don't forget to bring your special note for your secret snow buddy. And I'll see you guys in the morning. Until then, adieu.